Thanks everyone for coming along. It's great to have you here. And a big thank you to Jeremy Brown and Wen Yeow for joining us today to share some of their learnings. I'll start off by reminding everyone that today's session is recorded and we'll be posting the video along with the slides after the session in the next couple of days. Please use the Zoom Q&A feature throughout the session should you have any questions for the speakers. However, some or all of the questions may be answered at the end. There is also a chat bar on the right-hand side should you guys have any comments throughout. So we've got two great presentations lined up today. First up from Jeremy Brown on what happened when they asked a video dev to design a serverless API, followed by Wen Yeow on his EKS journey in one of the big four. So if you guys have any feedback or topic ideas, please scan the QR code seen on the screen or copy the link below so we can continue to improve these sessions. We're also always looking for different people to present or sponsor the meetup. So should you guys want to present, please email us at hello+meetup@polarseven.com and we'll get in touch with you. A few recent announcements from AWS in the last month. So you can now use AWS Code Deploy to deploy AWS applications to your virtual private cloud through VPC endpoints using the AWS private link. So a bit of a mouthful, but essentially using this feature, you can use Code Deploy to deploy your critical and internal applications without using an internet gateway, public IP addresses or a VPN connection. So Private Link provides a secure connectivity between your VPC and your AWS resources without requiring the traffic to traverse the internet or leave the Amazon network. So Amazon EKS pods running on Fargate can now mount Amazon EFS file systems, and the Fargate will use the EFS CSI driver to automatically mount an EFS file system without the need for manual driver installation. And lastly, so Amazon Fargate for EKS is now included in Compute Savings Plan. So whether you've already got a Compute Savings Plan, it will just automatically apply. Or if you've got EKS running, you can buy a savings plan to save on what you're purchasing. Head over to the About AWS What's New to make sure you stay up to date with all the newest services and announcements from AWS. So I'll pass it over now to Jeremy. Jeremy, you can introduce yourself and your topic.
Yeah, thank you, Jackson. So I'm going to take over your screen now. You're going to, there we go, sharing. You okay?
Yeah, we got it.
All right, mate. Okay, so Jackson, you're the only face I can see, so I'm going to present to you if that's okay. This is a bit odd. I'm used to probably more communal Zoom call, but we'll see how we go. So there we go. Hey, I'm Jeremy. I'm the Associate Director of Video Delivery at Optus Sport. Some of you probably know me through my time at Channel 7, but also I run the Sydney Video Technology Meetup. It's pretty popular. We're pretty similar event. We are missing being on a premises, that we are doing virtual events as well. I'm going to start my talk with a quick streaming video lesson for those who don't know how it works. And basically, oh no, the image thing. Okay, so the video is a manifest, is a list of playlists. So if you ever watch a streaming video, what you're seeing is a list of different playlists. In those playlists, we'll talk about resolution, about the quality, about the frames per second. The reason for this is if you're on a really good connection, you should see that really high rendition. If your internet starts to slow down, if you're on a mobile network and you're going through a tunnel, you'll start to move down in quality. And you've seen that experience of when you're watching a video and it suddenly gets a bit blurry and then it gets good again. that's how that works. But the manifest itself is just readable text. If you look at the readable text, you can see here quite simply where I've pointed out the resolution. The way it works in the playlist is for every rendition that has a playlist. In every playlist, it'll run through a list of videos. These videos are between 2 and 9 seconds long, and they tend to look like this: 1.ts, 2.ts, 3.ts. And so you just play, your player knows to pick up one file, play it through, play the next one, play the next one. Being that it's text though, it's super flexible. We can adapt quality behaviors. We can adapt around user experiences. The example I'd like to say is you probably don't ever need a really low rendition for a television because you're on a DSL connection, and you probably don't need a super 4K rendition on your phone because you're on your mobile carrier network. But the example I like to show off here is I've given every language through a caption translator that I've built in as a Lambda function to translate captions from English to pretty much any language. It's pretty easy to do. The delivery of video works much like any other API. I think that's pretty clear, isn't it? It's text files. It's an API that points you to other APIs, manifests to playlists. And then front-end developers come along and they often declare that it ruins their optimized website. And I totally get it, because you've spent days trying to shave 20 kilobytes of CSS or optimize your JavaScript. And then I've come along and loaded a lot of video. Videos are large files. They could be 7, 10 megabytes. They could be a couple hundred kilobytes for low quality, but it can get up quite high. The fact that those segments are in a few seconds long, you're constantly having to pull down potentially a 5 megabyte size file every couple of seconds. Now you think about an API that behaves like that, you'd probably get fired if you designed one like that. So it's doing that thing with the images, Jackson, but we'll let it go. Guys, you're just gonna have to deal with it. So watching 1 minute of video, you can see is quite chatty. This is a very low quality video and it made 386 requests in 1 minute. That's a nightmare for a front-end developer or for any API. Also, the other complications is that we're streaming, we're buffering. We're actually asking, prefetching this API well ahead of time because we don't want to have that buffering experience. We might be a minute ahead. We may never actually watch that minute, but we've buffered that video and we're holding on to it in the browser. This is where video really starts to fall apart, is that we've actually got different formats to support different devices. So most people will watch HLS on an Apple device. You can even get it to work on a lot of televisions and such. But the other big one's MPEG-Dash, Android devices and Chrome and so forth, especially but what am I trying to say here? So suddenly we've got to do this entire API twice, and maybe even 3 times if we need to do an Xbox Live and we need smooth, or maybe we've got some older devices that are running Flash and we need to go to RTMP. And then we have a unique DRM for each platform type. Now, DRM is a very controversial idea for web. Web's meant to be open and free and everything, but as content owners, we've won, and there's native DRM support in the browsers. So that just further complicates how our API works, how our players are built, the amount of complexity in their players to support this API that's called streaming video. So the typical delivery of any video, it looks pretty much the same as what you would do for anything else. You've got a device pulling off you through its network off a CDN. And you've got an origin where you try and create static assets to deliver out on. And each of those carries a cost. And so you've got to consider the CVC cost, the CDN cost, the origin hits, and then the carrier network, and then be sympathetic to the user and not use up all their data if they're on a mobile network, things like that. You're paying that CDN delivery as well. So if you want to deliver 4K streams, you're going to rack up a pretty good bill. But the internet is complex, and these costs become multiplied as you deliver from that origin to multiple telcos, ISPs and such. And a single CDN is a single risk of failure. You know, you don't want to have these single points of failure. If there's a problem with the origin or the CDN in that location, you need to be able to change over, especially on a major event. You know, I've just worked on the Olympics a few years ago. Melbourne Cup was another example. You know, we couldn't just rely on a single point of failure at any point. So you go to a multi-CDN option. Suddenly all your costs become multiplied. Suddenly your diversity is there, and you're creating far more complicated infrastructure to deliver on. Remembering this is just an API. And then you talk to live streaming, it gets way more complicated. Live streaming is continually moving pictures and video. VOD, you get an asset, you've got plenty of time to prepare it before the day. But with live, it's coming in all the time. And so you need multiple redundancies over multiple connection types, over multiple regions. You need at least 2 of everything. I think I've got 3 of everything here. And you need monitoring on those services. So go back to my picture. So video has a lot of moving parts. It's a constant risk of outage. It is of sorts an API when you break it down to just text files and video files and delivering at scale. So today I came to talk about EPG API. So EPG API was an EPG. There was 54 channels that we had live streaming. And we needed to know what was on them now, next, and later. Much like on your TV experience when you change the channels, it gives you a feeling of what's on now, next, and later. It is just text with some image links. It was a schedule. It was JSON, pretty basic stuff. It does need to be polled every minute. So we have all of our network of devices, how many people are watching our apps right now, that channel. They're polling every minute to make sure that the schedule doesn't change. You know, you watch broadcast television now, especially live sport, Super Bowl games in an hour early. Other games may play over. You need to be able to adapt to that experience. The reason we use poll and not something like WebSockets, purely because we had to deliver on so many devices. Not all devices supported all of this new I call it new technology. It's maybe not that new, but it is new when you think about a 9-year-old television that you might need to support. The EPG API use changed. It, at one point, was very user-centric. If you were paying, if you were a subscribed user, if you were logged on, you may have got a slightly different list of video channels to someone who wasn't. But over time, it just became free to air. If you land on our homepage, you got a list of channels. Everyone got the same list. It became universal. The stack was pretty consistent with anything built about 10 years ago, maybe 8 years ago, an EC2 Postgres platform. You know, it was time to refresh to serverless. And and so time to refresh to serverless. So, you know, I look at the drawings and the typical serverless patterns tend to look like this. There's your platforms over the internet to API gateway. You can turn on caching. You've got a Lambda function in a database, or you proxy off another entry point, proxy someone else's API, mangle it on the way through, push it back. The video developer in me just kind of didn't quite love this. So, you know, this seems overly dynamic, this API gateway, and where does the cache go? It comes off the API gateway, or is it in front of the API gateway? You know, I'm used to shielding an API behind a CDN. You know, CPM, it could get expensive if we're hitting it per minute across the entire network of devices for a couple of hours. You know, how does this scale? Look, don't get me wrong, Australia is a very small place. with a small population, and we probably don't do anywhere near the volumes of traffic that Amazon see on other networks. But it does concern me. It's something that I think about as a video developer. And don't get me wrong, I do like serverless, and I've always used serverless where I can, but I've managed to hurt its feelings a couple of times in the past, and I'll quickly talk on that. So this was the website load order. You go to an IP lookups API, and it basically gets you an indication if you're in Sydney, you're in Melbourne, you're in Queensland. And because you're in those locations, you watch the Sydney news and the Melbourne news and the Perth news, because region-based channels. With that location details, you go to the CMS API, you get the response, some trickery in React, and there you have a home page. But the 404 and the 500 page had a funny order of looking up the API, going to the CMS API responding with an error page, the error page then looking up the location. Does the error page really need to know what location you're in? Probably not, but this is what ended up happening. It kept refreshing and creating this massive amount of spike of traffic into our IP lookup API. And so this immediately looked like a denial of service attack, but we didn't realize that it was the load order on the error page. We were doing 5,000 Lambda executions a second. Could have gone higher. What ended up happening was a few users got the request to re-request as the header. And so it didn't go down, but it was having a very hard time, and it probably shouldn't have got there. And we learned very quickly what we'd done wrong. So go back to video streaming. So we see this kind of scale often. We see this huge amount of volumes of requests to our API manifests and playlists. And we see, if this is my math, please, if I've got it wrong, you can call me out later on. If we had 1 million concurrent streams running right now, we'd have 300 million requests a second. I'm basing that based on my 1 minute of watching a video. It's good enough. It's a good enough example. So 300 requests a minute is a lot of requests on an API. So we wanted to build EPG API for 1 million requests per second, and we didn't want to have an outage. We didn't want to have an expensive mistake. And one of the reasons why is if that EPG API went down, we've got 15 different applications. We've got TVs, Telstra TVs, websites, mobile apps, and they all behave differently. And potentially the EPG not being there was enough for the entire application to crash, which is bad. They can still watch the video, maybe not know what's on TV right now. That's not a bad experience. The EPG was quite large and the execution time was long in Lambda because of the 54 channels and the amount of sourcing that it had to pull from. So I kind of break it down and said, well, what is an EPG? It's on what's on now next. It's not user specific. It's constantly changing and it's verbose, but it's pretty good and static. I really like S3. I think S3 is probably the greatest product in Amazon's stack. If you really think about it, it's super cheap. It's feature rich. It's a life cycle. It has CloudWatch, it has security, it's Aurora, Athena. Anyway, S3 query, you can query the data. They constantly build these tools that drive off S3. Like it's clearly this amazing stack, this amazing tool that you can start building very large empires from. And it's been designed that way, designed that you could mimic an API. Yeah, we've all done it in our testing environments and our POCs, that you create folders for versioning and APIs and on now, and you drop a JSON file in there or an XML and you call it an API for the sake of the argument. Everyone in the company at that point understands what's going on. It's the same process as folders on your computer. You look at the folder, you see the file, you know where it is. You can build a monitoring system. Is the file there? Yes, good. You can upload files to update that API. I mean, you can see where I'm going with this. This isn't in the SLA, but written in the SLA is that AWS S3 has been designed for 11 nines reliability. That doesn't mean you get 11 nines, but it's designed for. If you put 11 nines into the calculator, it comes up with 0 seconds per year. But if you think about, I couldn't even put 11 nines in there. It would only let me put 10. But you kind of get a sense of how seriously they take this product and how reliable it is and how it's probably a really nice way to go in a lot of problems. So if you're like me and you work with a lot of CDNs, you learn that they all pull from S3 natively. They've all got to do it. For other customers, they do pretty turnkey click and play solutions to deliver off multiple CDNs. I'm not allowed to say their names, am I? Anyway, we all know who they are. But that's very little work, it really is. You want to go multi-CDN, put a file in S3, go to one of the other guys, click a couple of buttons, now you're multi-CDN. So most videos are actually streamed off S3. So when I talked about those TS segments, especially for VOD libraries, the source, the origin is typically S3, regardless of who we're talking about, the biggest players in the market. So that made me think, well, this seems obvious. We're going to build an EPG API that just puts files into an S3 bucket in 2 AZs, and we're going to deliver off 4 CDNs. Now we've got this huge resilience, haven't we? We've built this massively redundant system. There's no chance that it could go down. I'd like to think so anyway. And we're doing a per minute execution. So CloudWatch event to a batch, Lambda, Postgres, off an S3 bucket, some Cognito security functions, and publish it out over our CDNs like CloudFront and the others. So some of you have probably already cottoned on that I'm not just explaining event-driven architecture. And I really am, but I guess what I'm trying to say is, look, think about the other end of the event-driven architecture. Now that you've brought down to execution a push or a per minute batch or something like that, how do you create resilience on the other end? So, because the immediate benefits of this model for me was, you know, I have multi-CDN. I'm already paying for multi-CDN, so I may as well repurpose it for APIs. I have a static file facing the client. I have a fixed cost. It's 1,400 minutes in a day. There's 1,400 executions a day. If someone wanted me to say what per minute is too long a time in between, I could say that's fine. 2,800 executions, or we could go the other way. It's costing too much. All right, we'll run it every 3 minutes, and we'll bring it down to 600 executions, 400 executions. If for any reason the dynamic parts failed, they will go stale. The file on S3 will not get updated, but it won't go down. And so you can think about, in the experience that I had, the EPG will tell me that at 6:05, the news starts. And if it's changed to 6:06 or 6:10, it's not that big a deal. If it was gone down for a couple of hours, maybe it's starting to get a bit annoying. Back to the other part. Everyone understands S3. I can hand this over to an operations or a tech support team. They know how to get into a text editor and change it if they had to and publish it out. They could quickly publish out changes if they needed to. And believe me, in the moment of that major event, like the Melbourne Cup or like the football final, you will pay any money to have that flexibility on the day. Poisonless cache. Because the origin is static, you can't break through with a header or a query string that creates a new dynamic version of the same request. We've all seen this before, and it tends to rack up bills where you have a caching layer that might have a rule on a query string for some reason, or in a header that allow it through. So the end result, fixed cost. We actually had some AWS incidents last year, and we survived them. We went stale. We didn't go down. It was a simpler code base. Everyone understood how it worked. Just ran a batch execution every minute, put a file in. I like to think it was DDoS proof. Someone prove me wrong, but not on my API, please. Build your own and then try and break it. And ops were thankful because they understand the concepts. They understand how to monitor it. They could build very simple CloudWatch services around it. They could bail in and change it if they had to on the day. That was my talk, but I'm hiring. I'm going to take this opportunity. I need a solution architect working with me on stuff like this, exactly like this. An associate director in video engineering, which is probably more a networking role if you are into that sort of stuff or in broadcasting. And now I'm going to totally plug my event. That was me. If you don't know me, I run Sydney Video Technology also. We are a monthly online meetup at the moment, but we'd love to get back to the pub as soon as possible. On the 24th, we're going to run a special event. My images are gone. 24-hour meetup. There's actually 18 meetups, just like Jackson's meetup here. He's got around the world. We're doing the same thing. But what we've done is we've figured out that if we all play out over the day, we can have a 24-hour meetup. So there'll be, anyone who knows the Demux conference will know why we'll publish it. This is how it will work. Lots of entry points around the world, lots of people using different technologies and then pushed out. Switching sources to play out over the day. So there'll be lots of presenters on the 24th. If you want to come and talk, come and reach out to me. There's a few spots left. And Demux is the big conference. Thank you.
Great. There's just a couple, or there's one question from Kevin. So did you want to read that one out? Can you see the Q&A section? If not, I can read it out.
No, let me get here. Bloody Kev. Okay, I know could there be a latency when using S3 that might impact on media delivery? Look, Kev, for everyone who doesn't know who he is probably one of the smartest people in video streaming globally that I know. So he is talking through issues of latency, I assume, with live streaming. And I speak to VOD and live at the same time pretty freely. Might mean impact on media delivery on propagations to be delayed or area of. Look, I think Kev probably knows the right answer there. I can't quite tell whether he's trolling me or he's asking a legitimate question.
For everyone else's benefit, did you have a 5-second answer?
Yeah, look, there could be a latency, but we'd be talking in milliseconds, wouldn't we? And I guess the difference between video delivery is our files are enormous. They're 5 megabyte files. And I guess I was trying to talk to an audience of people who watch small text APIs pass through where it shouldn't be a consideration, I would think.
Right.
Anyway, and I also wanted to build an API that doesn't go down. So thank you, Jackson. This was great.
No problem. Just one more also from Arvin, but Arvin, we might just quickly answer that at the end if we've got time, if that's okay. Or if you could type an answer as well, Jeremy, just as we hand over to Wen, that would be cool.
Yeah, I'll try and keep on the chat. I'm going to mute my mic though, so you don't have to listen to me type.
Right, awesome. Well, thanks so much for that, Jeremy. It's very interesting hearing from a perspective of someone working daily in such a large scale environment. So I'll hand over now to Wen. Wen, you'll be talking about your journey in EKS.
Yes. Let me just share my screen. Yep, that's what I'm going to share. And cool. Good afternoon, everyone. My name is Wen Yeow, and I'm here to share our journey, our EKS journey in a Big Four. I work for a bank, and as you all know, banking and financial institution in Australia is a heavily regulated industry, and it comes with its own challenges. What do I do in a big bank? What does it mean by tech lead? I'm essentially the senior engineer. I chart the path. I try to understand where we are at, the kinds of apps that we run, and chart a path towards running containers at scale, securely, of course. And if I may, my background is Malaysia, and I'm just going to do a quick plug for Malaysia. So I'm from Malaysia. I grew up close to KL, and if you're interested in, if you like to eat street food and all that, that's, you want to focus your travels around the West Coast. That's where all the cities are. And if you heard of Laksa and Penang Laksa and all that, Penang is an island that's up here. So that's, if you're interested in food, but otherwise, if you're interested in nature and really smart mozzies, it will be somewhere in the middle here and all over the Borneo side. And if you're interested in beach and, pristine islands and all that, that would be on the East Coast. So would I see the pointer, my mouse pointer? Yeah,
we can see that.
Cool. All right, that was just a quick plug. Okay, so I wanted to write a slide to talk about the regulators, and I quickly realized how much how much I don't know. There's so many different organizations. I was looking for a picture to express that, and I found this picture in Google. And if you observe the lady here, she's saying, she has got a smile there, and she's got a finger pointing at the it's saying that there's a rule book for banks, and that's all nice and pleasant. If you just scroll over to the bottom right, you can see here really strong words about consequences and enforcement, and this is the tone, the setting, the environment that we work in, where security and compliance, it's paramount. This is another picture that I found on the website. Now, the previous picture doesn't even exist anymore. I'm not sure why, but this is a much more pleasant picture, I think. And it comes out of the ABA, the Australian Banking Association. So what is it like to work for a highly regulated financial institution? What's the view on ground zero? So I'm a senior engineer. What does it mean from my angle, right? One of the main concepts and features that are implemented in a bank is the concept of what we call shared responsibility. So every team is given like a set of AWS accounts, and believe it or not, even though we use the account, we are the main user of the accounts, but we are not the admins, we're not the administrators of the account. And there are 5 other different accounts with visibility into our account. So that's the environment that we have. And the other concept is the emphasis on segregation of duties. So we have different accounts for non-production and production. We have different set of roles for non-prod and prod. It's all clearly and intentionally separate. So that's the kind of, I guess, things that we work in. I promise this will be the last meme. The enforcers, they don't say no. I'm just making fun of the situation. But when I started, I quickly realized that we need to integrate with a lot of existing services in a bank. For example, we have Git as a service. We have artifact repository, we have code scan, we have log collectors, and each of these services are backed by a team. So there's a lot of integration work required. Hence, I think one of the main lessons that we learned quickly is that the choice of tool that we use in Kubernetes is going to be important to allow us to be agile kind of way, to not be tied into any particular implementation. So in other words, agnostic everything if possible. And there are built-in compliance and enforcements in our AWS accounts. Just to give you an example, I'll give you two examples. A compliant S3 bucket policy document, if it's compliant, it would have a minimum of 80 lines in the policy document, and that excludes our policy, just to give you an idea. Second example, EC2 instances have to be based off sanction AMIs. If you stand up an EC2 that's not compliant, it will be immediately terminated by robots that runs in all the AWS accounts. So what I'm trying to say is there's a very strong emphasis on compliance, and compliance are enforced in the accounts. Yeah. All right, the journey. When I first started in a bank in 2017 Q3, the team that I was in, they already had all the workloads in AWS. We were already running Terraform, Packer. We were using a bit of Docker, and we had TeamCity as our CI. And I walk into that kind of setting, and that is great because it sets the foundation for subsequent pieces. So in early 2018, I introduced kubeadm. Now, kubeadm is a lightweight Kubernetes provisioning tool. It's an official tool in the Kubernetes project, and it's becoming the building block for other cluster provisioning and cluster management systems like EKS and all that. We'll talk about that a little bit. And this is all running in non-prod. Around mid-2018, we had, the first batch of applications that we run in a cluster would be our microservices, and they're all Spring Boot apps. And by mid of 2018, we had about 500 Spring Boot pods. Each of these are JVMs. And when you run at that scale, you quickly realize what you need to do. One of the first lessons that we learned is you need to specify your resource limits. You need to specify your resource limits. If not, when you start like 100 JVMs at the same time, without resource limits, it's going to consume all the CPU memory of the worker nodes. So lesson number one, moving on. Yes, so from 2018 to 2019, we realized, that we could run our microservices in Kubernetes. It works. We had 20 plus environments. It's all running. It's stabilized. And we wanted to take things into production. So how do we do that? And apparently we can't. We had to work with various teams across the bank. We obviously cannot use kubeadm because it's managed by us. The appetite around that time is to use managed Kubernetes service, and that's where EKS comes in. Okay, and we made our case, and around the beginning of this year, we had a project, funded project, finally, where we engage AWS and Weaveworks to work with us together to productionize the EKS solution, and we'll talk about that shortly. So that's high level, roughly, our journey. Let's move on. Right, so why did we choose EKS? First off, it's managed by AWS. Specifically, the control plane is managed by AWS. And this is on the right-hand side, you will see, this is the ports that run in the kube system. And you will notice that you won't see any control plane ports. So just to give you an example, the screenshot below shows the control plane, the ports running in the kube system. And in a kubeadm provision cluster, you would have like API server, controller manager, scheduler, and all that. So this is something that, just FYI. Now, what about the worker nodes? So in EKS, the worker nodes are called data plane. There are 3 flavors. There's the Fargate, which is fully managed by AWS. And then there's the managed node, and then the self-managed node. Now, we had to go with the self-managed node because our worker nodes need to run bank's AMI. So there's no choice in that. It's chosen for us. Now, in terms of cluster endpoint access, there are a couple of options. There's public, and then there's public and private. And the cluster endpoint access is essentially the API server, the endpoint to the API server, and how one would access the endpoint. And again, this is chosen for us. We had to use private. Just FYI, none of our AWS VPCs are public facing, they're all private. Defense in depth, layers upon layers of controls between our AWS and public. All right, let's have a look at the EKS infra layers. On the left-hand side, over here, we can see the control plane. Now, this is a black box. We can't really see what's in there. But according to the documentation, it's auto scale, possibly EC2s that represents the control plane. Now on the right-hand side, this is what we manage. Blue color means Kubernetes, orange color means AWS, and this is our worker nodes. And within the worker node, you have the guest OS, which is the base of the bank's AMI. We have the kubelet, we have the Docker daemon, and we have the pods. Yeah, and it's auto scale across, so we have like auto scaling groups per availability zone, because we would like to target stateful workloads in the future. So that's I don't have a diagram here, but yeah. All right, so who manage what? So that's AWS manage. That's why I have a little border here. And this is hosted in AWS VPC. We don't have visibility on that again. The only thing that we see in our AWS account is this ENI that I believe is attached to the instances behind, attached to EC2 instances over here. And the way the worker nodes communicate with the control plane is through the endpoint, which resolves to the ENI that's in our AWS, in our VPC. Now, in terms of code, starting from the lowest layer, we have Packer. We'll talk about Packer shortly, but we have a Packer code that produces compliant AMI. We use TERRAFORM to provision the control plane and the data plane using that AMI. Once the cluster runs, once the cluster is up and running, we then deploy the pods. We deploy the Kubernetes configs into the cluster, and we use, how do we deploy? So we use this thing called GitOps pattern, in which the source of truth is in Git, and we have a process that continuously converge the desired state that's represented in the Git to the actual state. And in terms of Docker images, we choose to use ECR, and that's one of the best practices because ECR is right next to, it's right next to our cluster. So we use ECR for runtime purposes. All right, so we have to write a bunch of code. Where do we go from here? So one of the first things that we decided upfront is we need a pattern that will simplify the way we run the jobs. And we adopted this thing called the Three Musketeers pattern. And this pattern was first introduced by Frederic Lemay in the Sydney Docker Meetup in 2017. Essentially, it is a make base plus Docker pattern for building, for running anything, running Terraform, running Packer, running anything, doesn't matter. So if you see the brackets, that's the website, Three Musketeers, you can look it up. I think this is this is what Meetup is about. It's about the community. It's about sharing ideas. It's about the free drinks and pizzas. But yes, it's the pizza and drinks fueled discourse about amongst the fellow engineers in the community. And I hope in this Meetup I can give it back to the community. Okay, let's look at a quick example of a Three Musketeers pattern. So this is a very contrived example. Just bear with me for now. You have the makefile, and makefile is wonderful because it's so lightweight. The binary is like 1 megabyte, and it's available in most Linux distro. In this makefile, you have the target. We call it echo. We can call it anything, and here in the target, you have recipes. And in this recipe, we have like Docker run. We want to run Alpine that contains the echo binary that will then print out the string. And when you call make, it will print out the string. I know this is a very simple example, but step back and think about your CI, your CI agents, right? And for example, if you run Java, right? If your organization runs Java 6, Java 7, Java 8, what would be your agent requirements? You would need to install Java 6, Java. You would need to have like different kinds of agents. And using this pattern, you only need one kind of agent. You have operating system, you're going to make in there, and you have the Docker. And that's all you need. And that's the only agent type you ever need in your CR. And that's beautiful. We want to keep things simple in a very complex environment. Yeah. Right. In terms of AMI, so we're going to go from the bottom layer and then we're going to move up. In terms of AMI, there is a upstream official code base for the EKS AMI, and that's by the AWS Labs. That's the link. The source AMI of this is a Packer build. It's Amazon Linux 2. At a high level, it looks like this. You got the base layer, and then you put in some binaries, and you have a couple of shell scripts, mainly the bootstrap scripts. In the back, we have to use the sanctioned AMIs. So what we did was we mirror that repo and we swap out the Amazon, the source AMI, replace it with the bank's sanctioned AMI instead of Amazon Linux 2, update a couple of files, slap in 3 musketeers, and we have a beautiful repo that is CI agnostic, and that's beautiful. We can run it in Jenkins, we can run it in TeamCity, we can run it in any CI, doesn't matter. Right. I'm not gonna spend too much time in this, but essentially we use TerRAFORM to provision the cluster infrastructure, and that would be the control plane and the data plane. Most importantly, right from the start, we write down what are the lifecycle events that we want to handle. So these are the main lifecycle events. We want to be able to create cluster, destroy cluster. We want to be able to update existing cluster, specifically update worker nodes with new AMIs. So the bank, the infrastructure team of the bank produces hardened AMIs at a certain cadence. And there's like requirements for us to consume and update EC2 instances with the bank's sanctioned AMIs. And one of the workflow that we identified is we update, this is the update rollback, we update existing worker nodes from AMI version 1 to AMI version 2. And assuming there's a problem with that AMI version 2, we then roll back to AMI version 1. So these are the requirements for our cluster lifecycle management. All right, so like the Malaysian tip, I told you where to, if you want to eat, go to Western. So here, this is another tip from me. I know it's like pretty obvious, but we decided from the start that we want integration tests. Now, testing infrastructure, testing TerRAFORM, it's a funny thing. We don't do unit tests, although there are certain groups of people who, started talking about how you might write unit tests. We didn't have a lot of resources, and we decided from the start that integration tests would give us the biggest value. So we prepared integration tests for the lifecycle events that you saw before. So we have a schedule run. For example, we create a cluster, we test a cluster, we destroy the cluster, we make sure that everything is destroyed. All right, so provision, test, destroy, test. And we do that for the other lifecycle events. For example, the update existing cluster and then rollback. Yes, so we run this on a schedule basis. It requires upfront investment, but the value is priceless. give you an example. If you look at this screen, this is something that we discovered recently. So we had a job that runs daily for one of the lifecycle events. And this is a screenshot of our TeamCity integration tests in TeamCity. And if you look at the third column, you can see there are no changes in Git. And yet, you see here, there was a failure. So we investigated the issue, and Kubernetes it's not like a simple app, and you just look at the code, and it's a lot of pieces, and it's time consuming. And this job helped us to pinpoint where it might fail, and through our investigation, we discovered a regression. Specifically, there was a CloudWatch log group. So when you create EKS cluster, you can enable the control plane logging, and the logs flow into CloudWatch. So when you destroy the cluster, in the past, it destroys the CloudWatch log group. So right around June, there was a regression where even after destroying the cluster and the CloudWatch log group, it will come back alive. So I call it a zombie CloudWatch log group. And we contacted EKS team, and they confirmed that it was an issue, and they fixed it. So this is a benefit, right? We also run this test for pull requests. So that's another benefit. Okay. So we have the AWS layer, and you have the Kubernetes layer. And what happens if you have pods that need to make AWS API call? In the case of EC2, you would give it a role. In the case of Kubernetes, we need a way to do this. And in EKS, the way is called the INRA for service account, or IRSA. Now, and this is the bridge between Kubernetes and AWS. This is the bridge. So just to give you an example, this is a service account YAML. Service account is an entity, is identity that you would use for your pods, so that when your pods make an API call to the server would know that, oh, you are full service account, high level. So how does this work? The IRSA, the first thing is you would need to annotate the service account with an IAM role, step one. And obviously the service account would need to be mentioned in your deployment object, your deployment manifest. That's one. The second part of the equation would be the role. So in the role, in the IAM role, I've taken a snapshot, a snippet of the trust relationship of the role. So essentially what this document here says that if the caller is full SA, and here it's called the sub here means subject. Full SA is an identity that's recognized by the OIDC that's attached to the EKS cluster. So that's how it works. Full SA is not an AWS identity, it's an external identity. And through OIDC, it is able to say, hey, is full SA a trusted identity, and the OIDC that's attached to the EKS cluster is able to say yes, no, and if it's yes, it would then, the pod would then be able to assume the role and be given temporary credentials to make the API call. So that's IRSA. Right.
Sorry, just quickly, when we might need to just breeze through the last few so we can get through to the questions. We've just hit the 2 o'clock mark.
Oh, okay, it's time. Okay, sorry. Okay,
No
so
worries at all.
yeah, I'll go quickly. GitOps. So this is a GitOps implementation. It's called Flux. Yeah, so you put your configs in Git, and Flux will pull the configs on periodically and talk to the API server and deploy your Kubernetes configs. So that's GitOps. And if you use GitOps, how do you deal with secrets, right? So that's where we use this thing called the sealed secret controller. So in here, we have sealed secret CRUD, CRD, which is called custom resource definition. When the sealed secret CRUD exists, sealed secret controller will notice it, and it will use the private key to decrypt the sealed secret to produce a secret. The summary of this is you can then store sealed secrets safely in Git, because we don't want to have plain text secrets in Git. Logging. Fluentbit, your best friend, integrates. It can push logs to Splunk if you use Splunk or Elasticsearch. All this runs as pods. We call them management pods. It's a Japanese product written by a Japanese guy. That's why you see like Japanese kanji at the top. Okay, that was fast.
Great, so just a few questions come in. Can you see them?
Oh, wow, okay.
So just one from Kevin. When moving to EKS, did debugging issues become more complicated compared to the original Docker Team City?
Well, the Docker and Team City is more around how you run the jobs. If you're talking about issues relating to pods that are running in a cluster, that's different. We typically look at the logs in Splunk. So we use, let's go back to the slide, we use Fluentbit. Oh, crap. We use Fluentbit to push logs to one of these guys, even in kubeadm. So if there are any issues, we go to Splunk, find the logs, and troubleshoot.
Great.
Yeah.
So second from Bobby, and we'll try to get through these quickly. So Bobby, how do you communicate with your private EKS endpoint, e.g. tunnel via SSM plus Bastion?
Good question. We typically tunnel through the Bastion, but we also could potentially troubleshoot. We can run kubectl from the Bastion. So we have like Bastion with special roles to access the cluster. Or we can look at Splunk, or we can look at dashboards. Oh, how do you communicate? Yep. So when you say you, meaning like the human engineer from a laptop, that will be it. So moving on to the third question.
Cool, and two more. So one more from Kevin. Any reason not to use Three Musketeers with multiple remote contexts, i.e. run/deploy?
Run make files on multiple devices concurrently. Not sure what that means. Well, if you imagine the CI as really dumb machines, it doesn't know anything about the job that we run. Everything's encapsulated through make. We could have multiple. I don't know. I don't understand the question, but
That's okay. We can link up on LinkedIn or something should we want to take the take the conversation further. Thanks, Kevin. So last one from Neil Caldwell. Did you consider Jenkins X or other tech for GitOps?
Jenkins X has always been our target, but because we had we were working with Weaveworks, and Weaveworks wrote or created Flux and WeaveNet and other things, and so we had them on site to help us, you know, work out the issues. But Flux works pretty well for us right now. Yeah, it's one of the GitOps implementation where it's in cluster, it lives in a cluster. Yeah, there are a lot of different products for GitOps these days. So yeah, we may consider in the future.
Awesome. So I'll just take over the sharing for one more minute. Thanks very much for that, Wen. Again, it's great to hear from someone who's working day in such a big environment. So as mentioned previously, the recording and presentation slides will be posted in the next couple of days, and you can look at any past meetups online at the link here on the page. So just quickly, I'll do a quick poll. If you guys could just answer. So on a scale of 1 to 5, how would you guys rate today's session? 5 equals amazing. Great, I'll just give it two more seconds. Wonderful. So thanks everyone for coming along today. If you've got any suggestions on how we can improve, please do reach out with the QR code on the screen and help us grow the community. Thanks everyone. Again, thank you Jeremy and Wen for sharing your ideas, and we'll see you again next month.
Thank you very much.
Thank you very much. Thanks, Jackson and PolarSeven.
Yeah, this was awesome. Thanks. It was great.